Welcome to this model. In this model, we are going to see about the point-to-point protocol. Although HDLC is a general protocol that can be used for both point-to-point and multi-point configurations, and one of the most common protocols which we are going to use for point-to-point access is the point-to-point protocol. Today, millions of internet users who need to connect their home computers to the server of an internet service provider use PPP only, that is point-to-point protocol. The majority of the users have a traditional modem and they are connected to the internet through a telephone line which provides the services of the physical layer. But to control and manage the transfer of data, there is a need for point-to-point protocol at the data link layer. PPP is by far the most common, which provides several services. PPP defines the format of the frame to be exchanged between devices, and PPP defines how two devices can negotiate the establishment of the link and exchange of data. And PPP defines how network layer data are encapsulated in the data link frame. It also defines how two devices can authenticate each other. It provides multiple network layer services supporting a variety of network layer protocols. It provides connections over multiple links. It provides network address configurations. This is particularly useful when a home user needs a temporary network address to connect to the internet. On the other hand, to keep PPP simple, we can use several services which are missing. And PPP doesn't provide any flow control. A sender can send several frames one after the other with no concern about overwhelming the receiver. PPP has a very simple mechanism for error control. CRC field is used to detect errors, and if the frame is corrupted, it is silently discarded. The upper layer protocol needs to take care of the problem. Lack of error control and sequence numbering may cause a packet to be received out of order. And PPP doesn't provide a sophisticated addressing mechanism to handle frames in a multi-point configuration. Now let's move on to the framing technology. A PPP is a byte-oriented protocol. That is, framing is done according to the byte-oriented protocols, and this is the format of a PPP frame. Now let's see one by one. The first field is flag. A PPP frame starts and ends with a 1-byte flag with a bit pattern 011111110. Although this pattern is the same as that used in HDLC, there is a big difference. PPP is a byte-oriented protocol, whereas HDLC is a bit-oriented protocol. Right. The flag is treated as a byte, and the next field is address field. The address field in this protocol is a constant value and set to 11111111, which is a broadcast address, and during negotiation, the two parties may agree to omit this byte. And next is control field. This field is set to the constant value 11000000, imitating unnumbered frames in HDLC. So PPP doesn't provide any flow control, as I said earlier, and error control is also limited to error detection. This means that this field is not needed at all, and again the two parties can agree during negotiation to omit this byte. The protocol field defines what is being carried in the data field, either user data or other information. This field is by default 2 bytes long, but the two parties can agree to use only 1 byte. This field carries either the user data or other information. The data field is a sequence of bytes with a default of maximum of 1500 bytes. But this can be changed during negotiation, and the data field is byte stuffed if the flag byte pattern appears in the field. Because there is no field defining the size of the data field, padding is needed if the size is less than the maximum default value or the maximum negotiated value. And the next field is FCS, that is frame check sequence. It is simply a 2-byte or 4-byte standard. Now let's see how byte stuffing is done in PPP. The similarity between PPP and HDLC ends at the frame format. That's all. So whereas this PPP is a byte-oriented protocol, totally different from HDLC. As a byte-oriented protocol, the flag in PPP is a byte that needs to be escaped whenever it appears in the data section of the frame. The escape byte is 0111101, which means that every time the flag-like pattern appears in the data, this extra byte is stuffed to tell the receiver that the next byte is not a flag. So PPP is a byte-oriented protocol using byte stuffing with the escape byte of 0111101. And now let's move on to the transition phases. A PPP connection goes through phases which can be named as transition phase. The first phase is called dead phase. In the dead phase, the link is not being used, there is no active carrier and the line is quiet. When one of the nodes start the communication, the connection goes into this phase, that is established phase. In established phase, options are negotiated between two parties. If the negotiation is successful, the system goes to the authentication phase, and if authentication is required, or directly to networking phase. The link control protocol packets are used for this purpose. Several packets may be exchanged here. And the next phase is called authenticate. The authentication phase is optional. That is, if the two nodes may decide during the establishment phase not to skip this phase. However, if they decide to proceed with the authentication, they send several authentication packets, and if the result is successful, the connection goes to the networking phase. Otherwise, it goes to the termination phase. And the next phase is called network phase. In network phase, the negotiation for the network layer protocol takes place. PPP specifies that two nodes establish a network layer agreement before data at the network layer can be changed. The reason is that PPP supports multiple protocols at the network layer. If a node is running multiple protocols simultaneously at the network layer, the receiving node needs to know which protocol will receive the data. In the open phase, data transfer takes place. When a connection reaches this phase, the exchange of data packets can be started. The connection remains in this phase until one of the endpoints wants to terminate the connection. Although PPP is a data link layer protocol, PPP uses another set of other protocols to establish the link, authenticate the parties involved, and carry the network layer data. In the termination phase, the connection is terminated. Several packets are exchanged between the two ends for house cleaning and closing the link. And this powerful link, that is the set of protocols, three set of protocols which are defined to make the PPP powerful are LCP, AP and NCP. LCP is nothing but link control protocol, two authentication protocol and several network control protocols. At any moment, a PPP packet can carry data from one of these protocols in its data field. And if there is one LCP, two AP and several NCPs, data may also come from several different network layers. And the LCP is responsible for establishing, maintaining, configuring and terminating links. It also provides negotiation mechanism to set options between two endpoints. Both endpoints of the link must reach an agreement about the options before the link can be established. All LCP packets are carried in the payload field of the PPP frame with the protocol field set to C0 to 1 in hexadecimal. The code field defines the type of LCP packet. And there are three categories of packets. The first category, comprising of the first four packet types, is used for link configuration during the established phase. The second category, comprising packet types 5 and 6, is used for link termination during the termination phase. The last 5 packets are used for link monitoring and debugging. The ID field holds a value that matches a request with a reply. One endpoint inserts a value in this field which will be copied into the reply packet. The length field defines the length of the entire LCP packet. The information field contains information such as options needed for some LCP packets. And there are many options that can be negotiated between two endpoints. Options are inserted in the information field of the configuration packets, and the information field is divided into three fields, whereas option type, option length, and option data. And authentication plays a very important role in PPP because PPP is designed for use over dial-up link, where verification of user identity is necessary. Authentication means validating the identity of a user who needs to access a set of resources. PPP has created two protocols for authentication: password authentication protocol and challenge handshake authentication protocol. And the user who wants to access the system sends an authentication identification and a password. The system checks the validity of the identification, and password either accepts or denies the connection. So in this regard, we are going to see three types of packets used by PAP. So PAP is nothing but password authentication protocol, right? Now let's see the diagram. So the three packets used by PAP and how they are actually changed. Now, when a PPP frame is carrying any PAP packets, the value of the protocol field is 0xC023. The three PAP packets are authenticate request, authenticate acknowledgement, and authenticate not acknowledgement. The first packet is used by the user to send the username and password. The second is used by the system to allow access. The third is used by the system to deny access. The challenge handshake authentication protocol, CHAP, is a three-way handshaking authentication protocol that provides greater security than PAP. Here, in this method, the password is kept secret and it is never sent online. The system sends a user a challenge packet containing a challenge value, usually a few bytes. The user applies a predefined function that takes the challenge value and the user's own password and creates a result. The user sends the result in the response packet to the system. The system does the same, that is, it applies the same function to the password and the challenge value to create a result. If the result created is the same as the result sent in response packet, access is granted, otherwise it is denied. CHAP is more secure than PAP, especially if the system continuously changes the challenge value. Even if the intruder learns the challenge value and the result, the password is still secret. CHAP packets are encapsulated in the PPP frame with a protocol value C223 in hexadecimal. There are 4 CHAP packets: challenge, response, success, and failure. The first packet is used by the system to send the challenge value. The second is used by the user to return the result of the calculation. And the third is used by the system to allow access to the system. And the fourth is used by the system to deny the access to the system. PPP is a multiple network layer protocol. It can carry a network layer data packet from protocols defined by Internet: OSI, Xerox, DECnet, AppleTalk, Novel, and so on. So to do this, PPP has been defined a specific network control protocol for each network protocol. Thank you.